Hi, I'm Steve Seidensticker. Today we are going to install a battery, a receiver, and several other components into an MTH number 1 scale F7 AA diesel electric unit. This installation is relatively simple because we are going to use the electronics and sound system that originally came in the P3 version of the control system of MTH locomotives. MTH has set this locomotive up in a master-slave relationship. We're not going to change that. That is, these units must always run together. All of the components are installed in the slave unit. Most of the work involves removing the electrical pickup mechanism from the trucks. Let's get started. Here we remove the fuel tank, which is going to hold a battery, a charging jack, and an on-off switch. The fuel tank is actually held on by 6 screws, 2 of which are hidden, but we will uncover these screws first. One of the things I have noticed is that these factory installed screws are really tight. Okay, now that we remove that part, there's a screw here, one here, and one here. Here we're removing the bottom plate from the truck, and the reason we're doing this is to disconnect all of the pickup wiring from the wheels to the interior of the locomotive. And this is done for 2 reasons. One is to isolate the motors from the track pickup, and also to then remove any friction from the wheels that these pickup plungers would impose by continually rubbing on the back of them. You will see that the plungers just popped out, and here we see the interior of the truck. And one of the things that I've noticed about this particular truck, that it seems to be really well built, very heavy brass drive gears on the axle, fairly large components, and lots of grease installed at the factory. First thing we're going to do here is remove this particular screw from the base plate. Take a pair of tweezers and remove sort of the guard over the springs and the plungers. All right, very carefully remove the spring. And there's little sort of spacers that go between the spring and the pickup wire that holds these. And take the entire plunger out here. And take the screw out. And then take this pickup, the wires, the plungers, these screws, the guards, and everything, and essentially discard them. Do the same thing with I used to work in N scale and thought it would really be able to appreciate the fact that everything was bigger in this scale. And that's true. It's a bit easier to work with, but there's a lot more of the parts than there are in an N-scale locomotive. Now, the last thing we're going to do as far as the pickup mechanisms go is get rid of these sliders. They come straight out. And because, of course, we're putting a battery in here, we don't need any of this pickup. Ah, there the spring came out with it. Now, the last thing we want to do is clip off these little brass strips. And to do that, I'm going to get in there with a small pair of dikes. And there's one. There's the other. And we're done. All we have to do is put these screws back. This is the best power screwdriver ever made. Now, we just have to repeat this process on all 4 of the trucks. Now that we have the pickup mechanism removed from the trucks, it's time to remove the body of the locomotive. It's held on by 4 screws, 2 in the front, right near the front wheels, right here. See it? Get a screwdriver down there. And right here in the front. And let's turn this around. And we find 2 in the back, probably a little bit more accessible, but let's remove them. And once all the screws are out, the body comes off relatively easily. This is what the inside looks like. First item here with the green top is the smoke unit. It is the heftiest smoke unit I have ever seen on any locomotive. And here is the circuit board with the brains. And you'll notice the 2 screw terminals or wire nuts. They're at the very top. There's one covering a bunch of red wires and one covering a bunch of black wires. And guess what? Those happen to be connected to all the electrical pickups. Here are a bunch of wires that connect to all the different lights on this unit. It has marker lights, number board lights, a headlight, and a Mars light mounted right above that. The 2 wires that we're looking at right here trip a solenoid in the coupler that opens it up when you hit F8, I believe, on a DCC controller function key. Next, we're going to install a Tam Valley DRS-1 Mark IV receiver for Airwire. I've already put some double-sided foam tape on the back. We'll just peel it off and stick it down right here. Looks like a good out-of-the-way spot for it. And it has an external antenna that has a little self-adhesive on it. And we're going to attach the antenna right to the top of the smoke unit. Like right here. That turned out to be a bad place for it, so we moved it vertically and positioned it just behind the smoke unit. Next, we're going to attach the red and black wires that came from the the pickup circuit. Now let's cut them a little shorter and put them in the DCC out slots. The next step in the process was to wire or to mount an on-off toggle switch here right in the front of the fuel tank, and also a charging plug. This is a 5.5 by 2.5 barrel connector. It has 3 wires attached to it, or 3 tabs that you solder wires to. And the advantage of this particular arrangement is that when you plug in the charger, it connects the charger directly to the batteries and disconnects the batteries from the throttle. Now, in the main part of the fuel tank, there's just room enough for a good-sized battery. In this case, we're using an Airwire 6800 milliamp hour 14.5 or 14.8 volt battery, and it just happens to fit in here very nicely. And I have wired connectors so that we can just plug it in. These longer leads will go up through the floor of the locomotive and connect to that other board I just put in. Here we have routed the wires from the fuel tank up to the bottom of the locomotive, and they're now going to be routed into the inputs of the receiver board. Red always goes to the positive, and it is usually important when you're wiring these boards up that you get the polarity correct. And some of them, they have a diode that will protect the board from improperly connected power sources. It won't hurt the board, but the device just will not work. Over in some devices, they do not have this protection, and basically if you wire the board wrong, you will possibly ruin the board itself. I'm going to put a little slack in here so that we can move that fuel tank to get at the battery a little bit, give it a little stretch. And now let's just flip on the power on the front of the fuel tank and see if we get power indication on the receiver board. Yes, we've got some lights, and right now I'm going to grab the transmitter and turn it on, and it will search the frequencies that I can possibly transmit on and sync up to that frequency. And the way we can tell that it's synced up is when both of these lights, or excuse me, when the signal light comes on, which is this one right here, comes on solid. We have, I don't know if we can see it, but a green indicator light, little LED right here, that indicates that the motor is getting power, or that the unit's getting power. All right, now we have the 2 red lights on, and that indicates we're getting good power. However, when we added power from the battery to the locomotive, it would not power it up. And after much troubleshooting, we determined that the capacitors inside the locomotive drew so much power that it tripped the circuit breaker on the battery as soon as we started up. To correct this, we added a very large 1 ohm 10 watt resistor right here to the circuit between the battery and the receiver, and that has solved the problem.